In this problem, we're going to find where the function is increasing and decreasing, meaning find the intervals where it's increasing and decreasing, such that we have the function f of x equals negative 0.5x cubed plus 3x squared minus x plus 2. And we're dealing with the limitation that x is greater than 0 but less than 7. So when we find our intervals where it's increasing and decreasing, the first thing that we need to note is that our answers have to be only within the interval 0 to 7. So when you're dealing with a problem of finding where a function is increasing and decreasing, the first thing that you have to do is find your derivative. Your derivative tells you where you're increasing and decreasing based on where it is positive and negative respectively. So we're going to take our first derivative of this function, which, remember, when you take your derivative you will multiply the exponent out front and then subtract 1 from it, which gives us 3 times negative 0.5 is negative 1.5 times x to the 3 minus 1 is 2. Plus, and now we're going to multiply this 2 out front and subtract 1 from it, just like we did before, which gives us 6x. And then finally, do the same thing for this negative x, which gives us minus 1. The derivative of plus 2 is just going to be 0. The derivative of any constant is always just 0. So now that we have our derivative, in order to find your partition numbers given any derivative, you take the derivative and set its numerator and denominator equal to 0. That will give you your partition numbers. In this case, we don't have a fraction. We could make it one by putting all of this over 1, but since 1 can never equal 0 anyway, there's no need to go through this. So all we have to do is set our derivative equal to 0, meaning set f prime of x equal to 0, and solve, and this will give us our partition numbers. So we have 0 equals negative 1.5 x squared plus 6x minus 1. And unfortunately, this isn't a problem that we can just factor. So we need the quadratic formula to solve this. Remember, our quadratic formula is given the values a, b, and c, where a is the number multiplied to the x squared term, b is the number multiplied to x, and c is the constant by itself. Then we say that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can just plug in our values and this will give us our partition numbers. So we have negative 6 for b, plus or minus the square root of b squared is again just 6 squared, minus 4 times a is negative 1.5, times c is negative 1, all over 2 times a is negative 1.5. And when you plug these values into your calculator, you're going to end up getting 0.1743 and 3.8257. So with these two values, we now have the partition numbers of our first derivative. And that tells us where our original function can go from increasing to decreasing or decreasing to increasing. So we need to either make a table or a number line to test around these partition numbers to see where our function is increasing or decreasing. So we'll start with our partition numbers, 0.1743 and 3.8257. And now we need to test a number to the left and right of each of these values. So testing a number to the left, or a number less than 0.1743, we would normally want to pick 0 here, as it would be the easiest value to check. But in this case, 0 is not included in our interval, 0 to 7. So we need to pick a number that's greater than 0, but less than 0.1743. So we're going to go ahead and pick 0.1. Probably the next easiest number to actually plug in. From there, we're going to pick a number between 0.1743 and 3.8257. So we'll just go ahead and pick 1. You could also pick 2 or 3, whatever you're most comfortable with. And then finally a number that's greater than 3.8. So we'll just go ahead and pick 4. Remember, this number also has to be less than 7, and 4 fits that criteria. So we know when we plug in 0.1743, our first derivative will be 0, because we said it's one of the values that causes the first derivative to equal 0 when we plug it in. Back over here. And 3.8257 has the exact same result. So now let's check 0.1. When we plug 0.1 into our first derivative, we'll get negative 1.5 times 0.1 squared plus 6 times 0.1 minus 1, which ends up giving us negative 0.415. Which we can put right here. And now we'll repeat for this 1 and 4. We have negative 1.5 times 1 squared plus 6 times 1 minus 1, which ends up giving us 3.5. And finally, when we plug in 4, we have negative 1.5 times 4 squared plus 6 times 4 minus 1, which gives us negative 1. Now remember, with this table, we don't care about these actual values. What we care about is the sign. The fact that this number is negative, this number is positive, and this number is negative. Wherever your first derivative is negative, that is where your original function is decreasing, because that means you have a negative slope there. And wherever your first derivative is positive, that means your original function is increasing, because you have a positive slope there. So we can start this off by making our list. We have decreasing and increasing intervals. So let's go ahead and start with the decreasing intervals. Or actually, let's go ahead and start from our smallest number to make it easier. We're starting at 0. So from 0 all the way up until 0.1743, we said that our first derivative is negative, which means that our function was decreasing all the way until 0.1743. So we're going to go to decreasing and say from 0 to 0.1743, it's decreasing. Now notice that we also have a negative value here. when x equals 4. So that means if we go to the first value where we're no longer negative, when our first derivative is equal to 0, that's at x equals 3.8257. So from 3.8257 all the way until we reach our limit, x equals 7, our function is also decreasing. This -1 tells us that from 3.8257 all the way to 7 will be decreasing. So because we have two separate intervals for this decreasing, we're going to put a union between them to say that on both of these intervals, our original function was decreasing. Now we're going to go back to our table, and we're going to start back at this point 1743. And we know that from that value all the way until 3.8257, we had a positive slope. This 3.5, this positive 3.5, represents all of the positive slope values that you would get if you plugged any number between these two values in. So on this entire interval, our original function was increasing. And this tells us all the values for which our original function f of x is increasing and decreasing.